Hello students, welcome you all for the third lecturing session on the module 3 internal combustion engine in the subject elements of mechanical engineering. I am Krishna Prasades, assistant professor from the Department of Mechanical Engineering, MIT Mysore. In the previous two sessions, we have discussed with some of the important topics in the internal combustion engine module, that is introduction to the IC engine, two types of engines like external combustion engine and internal combustion engine, and later we are also studied the working principle of internal combustion engine, components of an internal combustion engine, then 4-stroke petrol engine and 4-stroke diesel engine, IC engine terminologies as well as application of IC engine. In today's class, we are continuing with the performance of an IC engine. Okay, in the performance of an IC engine, some of the important topics that is called mean effective pressure, indicated power, brake power, frictional power, efficiency. In the efficiency, we are again discussing with the two types. The one it is called mechanical efficiency, other one it is called thermal efficiency. Okay, so we are starting with mean effective pressure. What is mean by the mean effective pressure? The mean effective pressure means it is the mean or average pressure acting on the piston during the power stroke. Okay, we are already studied the working of 4-stroke engine. So in the 4-stroke engine, in order to complete the one working cycle, piston has to perform the 4 different strokes like suction, compression, power and extract, as well as crankshaft has to revolve 2 times. Okay, whatever in the suction stroke, the fresh charge of air and a petrol mixture enters into the engine cylinder through the inlet valve, and during the compression stroke the fresh charge it is going to compress to high pressure and high temperature, and during the power stroke spark plug ignites the air fuel mixture and that pushes the piston from top dead center to the bottom dead center. That means during the combustion of the fuel, the mean or average pressure acting on the piston during the power stroke, that is called mean effective pressure. Okay, so what is mean by the mean effective pressure? It is the mean or average pressure acting on the piston during the power stroke is called mean effective pressure, and the mean effective pressure is indicated by PM, and the formula regarding to the mean effective pressure, it is nothing but S into A by L. Okay, and unit for the mean effective pressure in bars. Okay, here what is mean by the S and what is mean by the A and what is mean by the L. Okay, here L it is called as the length of the indicator diagram. Okay, length of the indicator diagram, and A it is called as the area of the indicator diagram. Okay, A it is called as the area of the indicator diagram, and S it is called spring value of the spring used. Okay, it is the spring value used in the area of the indicator diagram. Okay, so here this is called bar per centimeter, and this area it is centimeter square, and this is called in centimeter. Okay, so this is called mean effective pressure. I repeat, what is mean by the mean effective pressure? This is the mean or average pressure acting on the piston during the power stroke, that is called as the mean effective pressure, and the formula is equal to S into A by L, where S it is called as the spring value of the spring used in the indicator diagram, that is bar per centimeter, and A it is called as the area of the indicator diagram in centimeter square, and L equals to length of the indicator diagram in centimeter, and mean effective pressure it is denoted by PM, and the unit it is in bars. Okay, next second one, what is mean by indicated power? Okay, so indicated power it is developed due to the combustion of the fuel inside the engine cylinder, that is called as the indicated power, or in simple words, the total power available inside the engine cylinder due to the combustion of the fuel, it is called as the indicated power. Okay, total power developed inside the engine cylinder due to the combustion of the fuel is known as indicated power, and the indicated power, it is usually denoted by IP, and the unit, it is called it as in kilowatts. Okay. So what is the formula for indicated power? IP is equal to PM into capital L into capital A into small n divided by 60 into 1000 and units in kilowatt. Okay. Here what does PM indicates, what does capital L indicates, what is A indicates, what is N indicates, and these things should be written. Okay. So PM, it is nothing but, we are already know, mean effective pressure. PM, it is called mean effective pressure in bar. L is nothing but stroke length in meters. A, it is nothing but area of the cylinder in meter square, and N equals to number of cycles per minute. Okay, number of cycles per minute. So this is called it as the indicated power. So what is meant by the indicated power? Indicated power, it is nothing but total power developed inside the engine cylinder due to the combustion of the fuel, that is called it as the indicated power. And this indicated power can be written for both 4-stroke engine as well as for the 2-stroke engine. Okay, listen here, for the 4-stroke engine, we know in order to complete the one working cycle, piston has to perform 4 different strokes as well as crankshaft has to revolve 2 times. That means here for the 4-stroke engine, the number of cycles capital N is equal to capital N by 2. Okay. Here number of cycles small n is equal to capital N by 2, where n represents the crankshaft speed. Okay. What does n represent? It is nothing but crankshaft speed. Therefore, we can modify the formula for the 4-stroke engine. IP is equal to PM into L into A. Instead of small n, now write capital N divided by 2 into 60 into 1000 in kilowatts. So this is for indicated power for 4-stroke engine. Similarly, other one for 2-stroke engine, again your number of cycles small n equals to capital N. Okay, that means now the formula IP is equal to PM into L into A into capital N divided by 60 into 1000 in kilowatts. So this is for indicated power for 4-stroke engine, and this one it is indicated power for 2-stroke engine. So this is regarding to the second one, indicated power. Next, third one, what is mean by the brake power? Okay, so we know that first we need to again recall what is meant by the indicated power. The total power developed inside the engine cylinder due to the combustion of the fuel, it is called indicated power. Okay, but the power, it is transferred from the piston to the crankshaft through various intermediate mechanisms like connecting rod and crank. So because of the movement of these components, some kind of power is going to lost. Okay, and the total power available at the engine crankshaft, that is called it as the brake power. Okay, here the power available at the engine crankshaft is called brake power, and it is determined by applying the brake. By applying brake. Okay. So what is the formula for brake power then? The formula for the brake power, that is BP is equal to 2 pi NT by 60. Okay. And what is mean by the torque T is equal to W into R into 9.81 divided by 1000. Okay. Your torque, it is measured in terms of kilonewton meter and Bp in terms of kilowatt. Okay, then what is the two parameters like W and R here? W is equal to net load acting on brake drum. Okay, net load acting on the brake drum, and R radius of the brake drum. Okay, R equals radius of the brake drum. Okay, next fourth one, what is meant by the frictional power? Yeah, so I am already told here the indicated power is nothing but total power developed inside the engine cylinder due to the combustion of the fuel, it is called indicated power. But the amount of power available at the engine crankshaft, that is called brake power. Here some of the amount of power is lost due to friction, that is called as the frictional power. Okay, and the frictional power formula, it is nothing but IP minus BP in kilowatts. So this is called as the frictional power. Next we are moving on to the efficiency. What is meant by the efficiency? Efficiency of an IC engine, it is nothing but here the amount of power developed or amount of work done by the internal combustion engine to the amount of heat supplied, that is called as the efficiency. Okay, efficiency, it is the ratio of work done or power developed to the amount of heat supplied is called efficiency. And for the efficiency, again two types, the one it is called mechanical efficiency, another one it is called thermal efficiency. Okay, and the mechanical efficiency, it is defined, it is denoted by Nmech. Okay, here mechanical efficiency is given by the formula, it is the ratio of brake power by indicated power into 100. Okay, mechanical efficiency, it is defined as the ratio of brake power by indicated power into 100. Similarly, for the thermal efficiency, it is nothing but it is the ratio of power developed, it is the ratio of power developed to the heat supply. Okay. Again, the thermal efficiency can be calculated for both indicated power and the brake power. So that means if the thermal efficiency of brake power, then it is called as the brake thermal efficiency, is defined as brake power by heat supplied. Heat supplied, it is usually given by mf into CV, where mf it is called as the mass of the fuel and CV it is called as the calorific value of the fuel. Similarly, indicated thermal efficiency, it is IP by mf into CV into 100. Okay, so this is called as the indicated thermal efficiency and brake thermal efficiency. Okay, so this is regarding to the performance of an IC engine. I repeat, there are 5 different parameters. First one is called mean effective pressure. Mean effective pressure, it is nothing but it is the mean or average pressure acting on the piston during power stroke. Formula, it is PM is equal to S into A divided by L, and it is denoted in bars. Indicated power, it is nothing but total power developed due to the combustion of the fuel inside the engine cylinder, that is called indicated power, that is planned by 60 into 100. Next, indicated power can be calculated for both 4-stroke and a diesel engine. For the 4-stroke engine, it is nothing but planned by 2 into 60 into 1000 in kilowatts. For 2-stroke engine, it is planned by 60 into 100 in kilowatts. For the brake power it is nothing but power available at the engine crankshaft, it is determined by applying the brake. And the BP is equal to 2 pi nt by 60 and the torque is equal to W into R into 9.81 by 1000. Frictional power, it is nothing but this is the difference between the indicated power and brake power. Then efficiency, there are 2 types. The one it is called mechanical efficiency, it is the ratio of brake power by indicated power into 100, and the thermal efficiency, it is the ratio of power developed to the heat supplied. For brake thermal efficiency, it is BP by MF into CV into 100. For indicated thermal efficiency, it is IP by MF into CV into 100. Welcome back, students. Now we are moving on to the numericals regarding to the internal combustion engine. We have already discussed some of the performance of an IC engines, like what is meant by the mean effective pressure, indicated power, brake power, frictional power, as well as the efficiency. In the efficiency, we are discussed what is meant by the mechanical efficiency and the thermal efficiency. Okay, now we are entering into the very first problem regarding to the internal combustion engine. Okay, so here the first problem regarding to the a 4-stroke internal combustion engine running at 4500 rpm as a bore diameter of 100 millimeter and a stroke length of 120 millimeter. Then the indicator diagram details are also given, that is area of the indicator diagram, it is 4 centimeter square, length of the indicator diagram, it is 6.5 centimeter, and spring value of the spring used, it is 10 centimeter. Calculate indicated power. Okay, we know what is the formula for indicated power. Okay, so indicated power formula, it is very simple, that is IP is equal to PM into L into A into small n divided by 60 into 1000. Okay, if it is 4-stroke engine, then small n, that is equals to capital N by 2, hence formula you will get changes into plan by 2 into 60 into 1000. Okay, now just write down the data they have given. Sorry, first one, it is called here the 4-stroke IC engine running at 450 rpm, that is capital N they have given, that is capital N is equal to 450 rpm. Then the bore diameter, that is called small d, that small d it is helps to calculate the area of the cylinder. Okay, here small d it is nothing but 100 millimeter, so that we can written as 0.1 meter. Okay, what is the area of the cylinder? Pi by 4 into d square. Substitute pi by 4 into 0.1 whole square, then area equals how much? Okay, so now we can calculate with the help of the, so now we are calculating the area. So area is equal to pi by 4 into 0.1 square, that is 0.1 square into pi divided by 4, that is area is equal to 7.85 into 10 to the power of minus 3 meter square. Okay, similarly then the stroke length also they have given, that is 120 millimeter, therefore L is equal to 120 millimeter, in meters we can write it as 0.12 meters. Okay, so now we get all the details, what is meant by the L, capital A, small capital N, but we don't know what is meant by the PM. IP is equal to plan by 2 into 60 into 1000, call it as equation number 1. Okay, so that is, then what is meant by the PM? So PM we need to calculate. We know what is the formula for PM. So PM is equal to S into A by L. Okay, here indicator diagram details it is already given. Okay, what is the value of S and what is the value of A and what is the value of L? It is already given. Substitute here, S equals 10 centimeter, A equals 4 centimeter square and L equals 6.5 centimeter. Substitute and calculate the value. Okay, here 10 into 4 divided by 6.5, that will be equals to 6.15 bars. Okay, so now substitute value of PM in equation number 1. Okay, IP is equal to 6.15 into 10 to the power of 5. What is the value of L? Value of L equals 0.12. Area 7.85 into 10 to the power of minus 3. And capital N equals 450 rpm divided by 2 into 60 into 1000. Okay, so now calculate the value of IP, that is 6 into 10 to the power of 5 into 0.12 into 7.85 into 10 to the power of minus 3 into 450 equals 254340 divided by 2 into 60 into 1000, that will gives rise to 2 into 60 into 1000, that will gives rise to, it is 2.11 kilowatts. Okay, so total indicated power equals 2.11 kilowatt. Okay, so this is regarding to the first problem. Next we are moving on to the second numerical, that is called a single cylinder 2-stroke IC engine. As a piston diameter it is 105 millimeter. Okay, write down the data. The piston diameter, it is nothing but small d, that is 105 millimeter, that will be is equal to 0.105 meters, and stroke length 120 millimeter, that is 0.12, and a crankshaft speed, that is 1500 rpm, and mean effective pressure, it is nothing but 6 bar. Okay, now we need to calculate the indicated power. We know that what is the formula for indicated power, that is plan by 60 into 1000. For 2-stroke engine, small n equals capital N, because here the piston has to perform 2 different strokes as well as crankshaft has to revolve only 1 times, hence capital N equals small n. Therefore IP is equal to plan by 60 into 1000. Okay, what is the mean effective pressure here? It is 6 bar. 6 into 10 to the power of 5. What is the capital value of L? That is 0.12. So hence we need to calculate the area. Area equals pi by 4 into d square, that is 0.105 whole square into pi divided by 4, that is 8.65 into 10 to the power of minus 3 meter square, that is 8.65 into 10 to the power of minus 3 divided by 60 into 1000. Okay, that is 8.65 into 10 to the power of minus 3 into 0.12 into 6 into 10 to the power of 5. That will, after solving these things, we have to get the value of IP, that is 6 into 10 to the power of 5 into 0.12 into 8.65 into 10 to the power of minus 3 into 1500 divided by 60 into 1000, it gives rise to 15.58 kilowatt. Okay, so this is regarding to the second numerical. I repeat, in the first one we are asking with the 4-stroke IC engine, I need to calculate the indicated power, that is 2.11 kilowatt. In the second one we are asking with the 2-stroke IC engine for the calculation of indicated power, that is 15.58 kilowatts. Welcome back students. Now we are entering into the third problem regarding to the internal combustion engine for the basis on the calculation of brake power, and the fourth problem we are going for the calculation for mechanical efficiency. Okay, so first we are going on to the third problem, that is the following readings were taken on 4-stroke internal combustion engine having the diameter of the brake drum, it is 1.5 meter, and the diameter of the rope, it is 10 millimeter. Load suspended on the brake drum, it is 100 kg, and the spring balancer reading is 5 kg, and the crankshaft speed, it is 200 rpm. Calculate the brake power. Okay, so first, what is the formula for the brake power? The formula for the brake power, it is nothing but 2 pi nt by 60, and call it as equation number 1. And here the calculation of torque, it is the formula, it is nothing but 9.81 into W into R divided by 1000 in kilonewton meter. Okay, here in order to calculate the brake power, we need to calculate what is the torque. For the torque formula, it is 9.81 into W into R by 1000. So here in order to calculate the W into R, they have given the one experimental setup. Here we are having the engine, and that engine piston, it is connected to the crankshaft through the connecting rod, and we already know what is meant by the brake power. The brake power, it is nothing but the total power available at the engine crankshaft by applying the brake, that is called as the brake power. Okay, in order to apply the brake, here the brake drum, it is coupled with the rope, and the rope, it is then connected to the pan. In the pan, the total load of 100 kg it is applied. Okay, so therefore here W we need to calculate. Then the load suspended, it is they have given. Okay, the load suspended they have given, it is 100 kg, and this rope, it is also connected to the spring balancer reading. It itself having the inertia of the kg, it is 5 kg. Therefore effective load W, therefore effective load W is equal to L minus S, that is 100 minus 5, that is total effective load, it is 95 kg. Okay, total effective load, it is called it as the 95 kg. Similarly, we have to calculate the effective radius of the brake drum. Okay, effective radius of brake drum, that is called capital R. Okay, observe here, this is the brake drum, and this brake drum, it is coupled with the rope, and the rope having the diameter of 10 millimeters. Therefore, for the effective radius, capital R equals diameter of the brake drum plus diameter of the rope should be considered. Okay, then divided by 2 for the calculation of radius. Okay, what is meant by the diameter of the brake drum? That is 1.5 meters. 1.5 meters divided by 2, that will be considered, and the diameter of the rope, it is nothing but 10 millimeter. Therefore, for the 10 millimeter, I can consider it is 0.01 meter. Okay, that is 0.01 meter divided by 2. Therefore, effective radius we need to calculate. Okay, for the calculation of effective radius, just take the calculator. 1.5 divided by 2 plus 0.01 divided by 2 should be add. Therefore, the effective radius we have get, that is 0.755 meters. Okay, once we got effective load on the brake drum and the effective radius of the brake drum, then we can calculate the torque, that is 9.81 into W, it is 95 kgs, radius it is 0.755 divided by 1000. Therefore, torque equals it is 0.703 kilonewton meter. Now substitute value of T in equation 1 for the calculation of brake power. Brake power is equal to 2 into pi into, what is the value of N? The engine crankshaft speed, it is 200 rpm. Substitute into 0.703 divided by 60. Therefore, brake power equals brake power equals 14.73 kilowatt. So this problem regarding to the calculation of brake power. So in order to calculate the brake power, first we need to calculate the torque. For the formula for the torque, it is 9.81 into W into R. Here for the calculation of the torque, we need to consider the effective load on the brake drum and effective radius. For the effective load on the brake drum, it is load suspended on the brake drum minus spring balancer reading, that is 100 minus 5, 95 kg, and the effective radius of the brake drum, it is here the rope, it is coupled to the brake drum. Therefore, dB plus dr divided by 2, hence the capital R equals 0.755. and the total brake power we get it is 14.73 kilowatt. Next we are moving on to the last problem regarding to the today's session. It is called a 2-stroke diesel engine as a piston diameter of 200 millimeter. Okay, just write down the data. Diameter it is 200 millimeter. Therefore area becomes 0.2 whole square into pi divided by 4, that is 0.0314 meter square. Okay, then the stroke length they have given, that is 300 millimeter, that is 0.3 meter. Then it has a mean effective pressure PM, it is 2.8 bar, that is 2.8 into 10 to the power of 5. Then the speed, the crankshaft speed they have given, that is 400 rpm, and the diameter of the brake drum, okay, diameter of the brake drum dB it is 1 meter, therefore the radius become 0.5 meter, and effective brake load they have directly given, W equals 64 kg. Find IP, BP, FP and mechanical efficiency. For the 2-stroke engine we know the formula, IP is equal to plan by 60 into 1000. Okay, so we already know what is the value of PM, it is 2.8 into 10 to the power of 5. L it is nothing but, what is the value of L, it is 0.3. Area 0.0314. N it is nothing but, what is the crankshaft speed, it is 400 rpm divided by 60 into 1000. So calculate value of IP, that is 2.8 into 10 to the power of 5 into 0.3 into 0.0314 into 400 rpm divided by 60 into 1000, which gives rise to IP equals 17.59 kilowatts. Okay, then we need to calculate what is the value of BP. For the BP, formula equals 2 pi NT by 60. Okay, so for the torque we know the formula 9.81 into W into R divided by 1000. Okay, 9.81, W it is 64 kg and effective radius it is 0.5 divided by 1000. So calculate value of torque, that is 9.81 into 64 into 0.5 divided by 1000, that is 0.313 kilonewton meter. Substitute value of torque for the calculation of BP, that is 2 into pi. What is the crankshaft speed they have given, that is 400 into 0.313 divided by 60. Okay, calculate the value of BP, that is 2 into pi into 400 into 0.313 divided by 60, it will give rise to 13.14 kilowatt. Okay, now we have calculated the value of IP and BP. Next it is very easy to calculate the value of FP. FP it is nothing but difference between IP and BP, that is 17.59 minus 13.14 FP, it gives rise to 4.4 kilowatt. Okay, next last one we need to calculate the mechanical efficiency. For the mechanical efficiency we know what is the formula, that is BP by IP into 100. Okay, what is the value of BP, that is 13.14, 17.59 into 100. Okay, therefore mechanical efficiency we are getting, that is 74.7% is the mechanical efficiency. Okay, so this is regarding to the numericals on the consideration of IP, BP, FP and the mechanical efficiency. So this completes the internal combustion engine on the module 3. Thank you.